Now that we have the temperature at the selected points from the numerical solution, let's move on to post-processing. So I'll go to mechanical. Before I do the post-processing, I wanted to show you that you can actually check what element type was used. So if I go to solution information and come here and do Control F and search for type, and I say next, 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 I have to go down a few, and I see, and that's where I want it to be, and I see that the element type is plane 77. This is you know, a special element type to impose the convection boundary condition. It's just the details of how it gets implemented in a general purpose solver, so don't worry about that. But if you look at plane 77, you can go into the help, which I've seen students are loath to do. You can search for plane 77, and you can see that it actually has the mid-side nodes, and you can look at the order of the interpolation. And that's where you can confirm what is the order of the interpolation. Okay, so let's take a look at the temperature contours. I'll highlight solution in the tree, and I'll say thermal temperature. And then I'll right click on this and say evaluate all results. I can also click on solve. I like to say evaluate all results to remind myself that that's post-processing. And that's very quick because it does not involve the inversion of the stiffness matrix. What it did was it went to get the temperature value at any arbitrary location. It's just doing an interpolation from the 8 surrounding nodal values, and that's quick, as opposed to having to invert a stiffness matrix, which tends to be the most time-consuming part. And you might not see the mesh over here. You can turn the mesh on or off by selecting show elements or say no wireframe. And you can change the display. You can go from contour bands to smooth contours. That's a nice pretty plot which you might want to try to impress your boss with. Or you can go to ISO lines. Not sure why this is breaking up. It might be a video card display issue. For visualization, you need a good video card. But for our purposes, this is good enough. Okay, so let me go to smooth contours, and I can also change the color bar. So I can come in here and I can click on something, and I can increase the number of contours. I can also change these values by right clicking and saying edit, and I can play around with these. One thing to keep in mind is that these max and min you cannot change, but you can change all the other values. I'll just reset it. I'll just go here and let me see if I can get it. Okay, reset all. So it goes to the default color bar view. And I can probe the temperature. So if I highlight probe here, and I can move the probe along, and it'll tell me the corresponding temperature value. And that's in degrees Celsius. So I can see that over here it's 1, red is 1, so that's a check on my boundary condition. And if I go to a location like this and look along the horizontal line, I see that the left boundary is hotter than the right boundary. Now there's no heat leaving the left boundary, but there's heat leaving the right boundary, so that makes sense that the right boundary is colder than the left boundary, which is hotter. And one can also take a snapshot. So one can go here and say image to file, and then you can say OK, and you can save it to a PNG file, say on the desktop. You can give it an appropriate name. I have my usual underscore. You could also use the Windows snipping tool. So if I say snip, and I can just mark out the area where I want to snip, and I can save it. I won't do that over here. So that's, that's the temperature contours that comes from the interpolation. And let's take a look at the heat flux next. But before that, I'll save the project.